So again, you need to come here to extensions. You need to go to get add-ons. You need to get XLMiner analysis tool pack, and you need to install it. Of course, you have to say yes. You can have my firstborn and all that crap. And then it pops up. We're gonna start it, and it's gonna sit over here on the side for right now. What you're gonna be doing, as is mentioned in the thing, you're gonna like a candlestick, table leg, what have you. It is rotationally symmetric. Let me show you something I mean, like this guy perhaps. Table leg. Not the, yes, groom. This would work. How exciting. The rotationally symmetric portions, yes? Dude, that's easy. It's not terrible, okay? What about, I don't know, this one right here? You flint, you a candle stick holder, I mean. Oh, you mean like this guy? Sure. You mean like some of those? Like this guy here? That would be perfect, actually. Now, what you're going to be doing, let's say you want to measure the diameters from hither to thither. Hither to thither. Now, what I would do is I'd turn it on its side like this. This would be the x-axis that runs down the middle of it. And you'd be measuring the diameters. Okay? So what I'm going to do is I'm going to do x, and then I'm going to do radius. Now, are you with me? I'm going to measure the diameter, cut it in dos. Si es bueno? Si. So let's say I measure every millimeter. I don't know, whatever. I'm just making stuff up. Maybe centimeter. Whatever, done. And then here are my data points. 0, 1, 1.2, 1.4, 1.45. 1.8. These are the radiuses. I've already cut them in half because I'm like that. Okay, great. There they are. You with me? Now, guy can go to insert, chart. He's going to make this. That's not what I want. I want a pivot. I mean, I don't want a pivot. I want a scatter plot. Boom. Grim, that's terrible. Oh, you're right. I know it. No, that doesn't look like it's. Well, that would work. Let me try a different one here. I forgot. I forgot what I was doing for a minute. We'll try it again. So insert graph. Scatter plot. Oh, that's mucho better. Now, under customize and save with Liberty Mutual, you're going to go to customize, you're going to go to series, I. You're going to go to trend line and data label. The trend line, by definition, is linear. We want a polynomial, is what we want. And perhaps I give it a, I'll show you what I mean by that in a second. Now, show me your r squared. Of course, we'll show the equation on the map like thus. This is pretty good, actually. Could I do a cubic if I wanted to? Sure. Is it better? That's actually really good. Okay? So that would be your function. Are you with me? This is the x-axis. This would be your function of x. Now I can use the discs or washer method to find, you see, the volume of this part of the shaft. Now, the next part of the shaft, let's say this guy right here, let's say I just did this piece here, yes? And then let's say from hither to thither, it's a different amount. So this would be 9, 9.1, 9.10, whatever. On the x-axis, maybe zeros on this end, you know what I mean? So maybe I have to take Joey, I might have to take breaks into 1, let's say 2, 3, 4, maybe 5 or 6 parts. Who knows? So you have 5 or 6 different polynomials. Okay? But then you find the volume of each of them and add them together, you're done. Now, it's an interesting question. Thank you for asking it. Joey says, but Groom, mine is hollow. It's an eighth of an inch thick. Thick. Well, then if you come back into here, move this piece of crap out of your way. And I can do inner radius. If you know the thickness, then the inner radius is simply the outer one minus the thickness. Are you with me? And that would be your new one. And then you could also just, and then hit control. Oops. Hold that, hit control. You drag this, insert, chart. Once again, make that a scatter plot. And one would think that one would probably use the exact same thingamajig. So I'm going to go polynomial. I'm going to do a third degree. And what it should be very similar to the last one. In fact, it should be exactly the same as the last one, except for the y-intercept. And if you look, sure looks pretty similar. 0.16x, 0.16x squared, etc., etc., etc. 0.973. But the only difference is that we subtracted 0.125 basically off of your y-intercept. Ta-da! And so you could do the outer radius, inner radius, and there you go. That's what's happening. It's exciting. If you need help measuring, I'm your guy. Just ask. All right? Bye.